Hi, all. Welcome back to our YouTube channel. Topic that we will have a look at today is from FRM level 1 and it's from paper 2, that is quantitative analysis. Topic is on mean, median, and mode and interpretation or on skewness. So basically, we will have a look at calculation of mean, median, and mode and how that can be used to interpret skewness of the distribution. Mainly, calculation part may not be asked in the exam, but interpretation of skewness is something is very important from FRM level 1 curriculum. So let's have a look. And yes, before we go ahead, please do subscribe to our channel. It takes a lot of efforts to come up with videos like this. So you have been given some data. So like you are asked to calculate mean, median, and mode. And the main part over here is like how do you interpret skewness of the given data and verify if it's a normal distribution. So easy way to do this thing is just check if your 68% of data is within one standard deviation. Of course, we will not calculate the standard deviation of this data, but yeah, that's the very good point to interpret if you want to verify if your distribution is normal. But over here is if we just check skewness from that also we can interpret if the data is your normal distributed or not. So this is something like this is a you can imagine this data as a marks of students of the class where in total there are 50 students. These are the marks uh, divided into the various interval like 0 to 9, 10 to 19 and all the way till 70 to 79. So there are two students who have scored between 0 to 9. There are student who have scored between 10 and 19. Likewise till 70 to 79. And this is a midpoint. We may not need it, but just for some calculation perspective, we may need in mean median in between steps. So we just take midpoint of all the class intervals. So 0 to 9, if you just divide this by 2, you get 4.5. 10 to 19, you get 14.5. All the way till 70 to 79, you get 74.5. And this is a cumulative frequency. When I say cumulative frequency, it's just like over here 0 to 9, there are two students. 10 to 19, there are eight students. So total students who have scored less than 19 are 10. So you add this 2 and 8. So cumulative frequency for this is 2. You add 2 to 8, you get 10. You add 10 to 6, you get 16. And likewise 16 to 10, 26, all the way till last class interval, you get 50. That is total number of students. And this is kind of deviation, you can say. So like firstly, we have to check which is a median class. So when I say median class, there are total 50 students. If I divide this by 2, I get 25 and 25 lie somewhere in this interval. So there are 26 students in this and 16 student over here. So somewhere 25 would be in this class interval. So this is something which would be tagged as a 0 and below this class interval, deviation would be -1, -2, -3. You can just think of one standard deviation, two standard deviation, but it's not standard deviation. You can, for sake of understanding, you can just say this is a deviation, -1, -2, -3. For these intervals, it's 1, 2, 3, 4, and likewise, and this just a calculation, FIDI, that is frequency into your distribution. So this is your frequency. 2 over here, deviation is -3. So product of frequency and deviation is -6. Likewise, it is done for all the classes. And total summation of this is 19. This we would need for some calculation. So that's why we have calculated over here. And this is just for your visualization. Over here, we calculate cumulative frequency in terms of numbers, but if you were to calculate in terms of percentage, so like two students out of 50 are in 0 to 9. So 0 to 9 interval would occupy 4% of total area under curve. You can think of that in that way. And 10 to 19, there are around 10 student out of 50. So that is 20% area would be between 10 to 19 class. So likewise, it can be calculated for all the class interval. So this is a data. Perhaps you would be given just a class interval and frequency. These midpoint, cumulative frequency, deviation, product of deviation and frequency, that's something you had to calculate. Of course, not from FRM curriculum perspective, but there are various courses in stats or other courses are there wherein you are asked to calculate mean, median, and mode, and then further interpretations are asked. But from FRM standpoint, you might be given mean, median, and mode. You just had to get an idea how do you interpret that, if it is negatively skewed, positively skewed, or uh, there is no skewness in your data. So that's what you are expected from exam FRM exam point of view. So let's see how do we calculate mean, median, and mode if we were to calculate just for knowledge perspective. So see, this is a formula for your mean. So this is the assumed mean. So when I say assumed mean, it is a average of your median class. So wherein your deviation is 0, you can take average of that. So 30 and 39, take average of that. So that has been taken as 34.5 plus product of frequency and deviation over total number of students. This we calculated product was around 19, and in fact it was exactly 19, and total number of students are 50, and width of class interval, if you look at the width, it's 10. So multiplied by 10. So if you calculate, this is a mean of the data. And when we talk about median, uh, the formula is slightly changed. Instead of assuming, we have lower limit of the median class. So lower limit, if you see, it was 30, but because data is not continuous, what we do, we just subtract zero point 0.5 from the lower bound. So lower bound will become 29.5, and n over 2, that is 50 by 2, that is 25, minus m. So this is tricky. When you talk about m, it is a cumulative frequency of the preceding of median class. So this is your median class 30 to 39. So cumulative frequency of preceding class, it is 16. So we have substituted that 25 minus 16 over 10 times 10. This 10 will get cancelled and you will get median as 38.5. Likewise, there is a formula for mode. For mode, your its lower limits remain same, but it is for a modal class. So for when you're calculating a mode, you have to consider a class wherein there are maximum number of students. So in this case, it's 12, and the lower limit of this modal class is 40. So we have used this 40. F1 is your frequency of the modal class, and F0 is frequency of the preceding class to the modal class. So it's 10 and 4. So we have substituted that. So 12 minus 10 and upon 2 into F1, that is frequency of your modal class. So it would be, I think it should be 12. So 2 into 12 minus 10 minus 4. It would be around 38.3. If you notice, I think it's not really 38.3. The mode is this 40.59. Just a rollover mistake. So it's 40.59. So now you have got everything. Your mean is 38.3. Your median is 38.5. Again, I'll just strike this. This is your mode. This is your median. Mean is your 38.3, median is 38.5, and your mode is 40.59. So now we have to just visualize and interpret our data. So this is how your data would look like if you plot histogram. So like this was a midpoint, And if you connect this area, this is your distribution. So this blue line all the way till this line, this is your probability function. Entire 100% of your data lies in this range. At a mean, the data exactly gets divided into 50-50. So at 38.3, somewhere here, the data, the this curve that you see in the blue line, with x-axis will have the 50% of data on its left and 50% of data on its right. So this is how you plot your histogram. It's a good thing to explore. You can try taking this data in your Excel worksheet and try to plot this histogram. And now back to our question, we were asked to uh, comment on the skewness and interpret if the data is normally distributed or not. So if you look, this is a thumb rule. If your mean has slightly shifted towards the left and followed by median and followed by mode, so then your distribution is negatively skewed. So and it applies in our case also. If you look at our mean, it was 38.3, median was 38.5. So 38.3, 38.5, and your mode is it's 40.59. Lot of typos in this slide. So 40.59. So this is mode. So this relationships hold true. We can say that distribution is left skewed or negatively skewed. And if your distribution is negatively skewed, you can directly say that your data is not normally distributed. So that's what we were asked to comment on the skewness and normal distribution, validation of normal distribution after computation of your mean, median, and mode. Hope you like the video. If yes, please do share with your friends, peers, and people who are preparing areas of various areas of statistics. And please do subscribe to our channel. And if you have got any doubt, please comment in the comment box. We would be happy to address. Thank you. Stay connected.